Calculus, simply put, is the study of change and variability, and it's used when we look at anything that changes speeds or anything in motion. Calculus came about in about 1684 is when we can say that calculus was actually discovered. And in fact, it was co-discovered by Newton and Lubensky. They lived in different parts of the world trying to work through different questions of that was pressing at that time, but yet they end up developing the same form of mathematics, which we now call calculus. Let's look at Newton's invention first. One day he was visiting with his friend um, Edmund Halley, you know, the guy whose Halley's Comet is named after. And he was talking to Newton, and Newton was saying, and Halley was saying how he was trying to figure out the paths of the planets. And he knew that the planets traveled in an elliptical pattern, but he could not predict the position of the planet on any given day because the velocity of the planets changed at different points in the elliptical path. And so Newton went to his desk and pulled out a piece of paper and gave it to Halley and said, "Hey, try this." And it was a new math that Newton had been working on, discovered a few years ago, and it happened to deal with the changing of velocity. And Halley was so excited. He ran home and he figured out how to find the paths of the planets using this new math. A few months later, Gottfried Leibniz published a paper in which he was trying to answer the question of slopes of tangent lines at various points on a function. And his discovery used a new type of math as well. Newton read his paper and he was very, very angry because although Leibniz's notations were different than his, it was his calculus. It was the math that he had invented. And he was saying that Leibniz was trying to steal his idea. And then Leibniz, of course, said that no, he published the paper first. He came up with the idea, and Newton was still in it. And so this is still a debate today about who discovered calculus. And in most cases, we just say that it was co-discovery by two different people in two different areas of the world trying to conquer two different concepts that was pressing to the day. As you can see behind me, calculus not only answers those two big questions, but many, many more questions can now be answered through using calculus. And there's two main areas of calculus: differential calculus and integral calculus. And as you can see on this chart, there's things that we can do without calculus. Say we can find the slope of a line. But with calculus, we can find the slope of a curve, something we couldn't do before. And we could find the average rate of change. Now we can find the instantaneous rate of change. So these are all wonderful skills that calculus has given us the ability to work through. We also now can find a tangent plane to a surface. We can find the maximum height of a curve. We can find the curvature of a curve. We can find direction of motion along a curve. All things that prior to this discovery of calculus was problems that we could not solve. And that's all with differential calculus. Now with integral calculus deals more with area and volume and area under a curve. So instead of using those geometric formulas that we had, finding areas of triangles and rectangles, we now can find areas of odd shape objects, any weird shape object. And we can also find the volume of these different objects and the lengths of the curves of these objects. So for our calculus course, I like to think of calculus as a house, and we're going to build the house of calculus this year. And anytime, if you know anything about building, the first thing you always want to build in any house is you want a solid foundation. And if you have a solid foundation, if you build your house with a foundation of concrete and steel and bricks, then that's going to be, it's going to withstand the test of time, and it's going to hold up. And so our foundation of calculus is simply limits. And this is what we're going to base everything else on. In fact, any other study of calculus can be traced back to limits. So it's very important in this first unit that you have a very good idea what a limit is so that you can understand the rest of calculus. And once we understand limits, then we're going to start building our infinite house of calculus. And in it, think of it as like two families living in this house. And the house is divided into two sections. And that's what we're going to do. We're going to divide our house into two sections. And we're going to look at, as you notice this house I'm putting arrows on the end. I'm building this house. It goes on to infinity because in real life, we haven't even touched everything that calculus can do. And this house keeps going, and we keep learning new approaches to calculus every year. But back to my two things of calculus, dividing up the calculus into two areas. And we're going to focus on this information this year. In our first semester, we're going to focus on the study of differential calculus, or another word we use is derivatives. Okay? A derivative, dy dx, is one of the notations for derivative, and that is the study of objects in motion, rate of change. It answers those questions that Newton and Haley were trying to answer earlier. And that's what we're going to spend our first semester on. And then after we get a very firm understanding of what derivatives is, we're going to move over to integral calculus. Integral calculus, on the other hand, focuses on the question of area and volume. So when we study integrals, which notation is the integral of dx, this is what we look at trying to answer the question of what's the area of an object under a curve? What is the area of odd-shaped objects? What's the volume of this? And so those are just some of the questions that we answer with our integral calculus, our second semester of calculus. And this is what I like to call my house of calculus. So we have a foundation of limits, and the house is divided into two sections, derivatives and integrals. And we're going to work on learning about all three of these things this school year.